This is the screencast for section 3.2, example 6. We're going to model some U.S. populations using exponential regression, or the U.S. population. So we're going to use 1900 through the year 2000 data and exponential regression to predict the U.S. population for 2003. Now we see that that data point is actually already here, but we're using that to compare with the data points that we are going to use up to the year 2000. So I've entered the data into my calculator in by stat edit. I've entered my data into list 1 and list 2. So I use 1900 as the year 0 and then 10, etc. So now I'm going to go to second stat plot, turn plot 1 on. I like data points being just those little decimals. My X values are in list 1. My Y values I put into list 2. And then now I'm going to hit zoom 9, which is zoom stat. So I can see the growth of this US population. But now I'm going to go to stat, calc, and I'm going to go to exponential regression, which is, I think, number 8. Number 0. There it is. Exponential regression. My X values, again, L1. My Y values, L2. My Y frequency list, I can leave that blank. I want to store the regression equation into Y1. And let's see what happens. So in my graph, I can see the exponential growth function following my data points. Now specifically, the problem wanted me to compare the results of the year 2003. So I'm going to hit trace, and then 2003 would be actually 103 for an X value, because that'd be 103 years after the year 1900. Oops, go to graph. Trace. I'm going to make sure I'm not on the plot. I'm going to hit up. I'm going to go to Y1. That's what I want to enter the X value 103 on. So my 103 years after 1990, my population was 301.21. Oh, by the way, that was populations in millions. It's not just 301 people. It's actually 301.21 million people. So 301,000, well, 214,530 is as accurate as I can get. They said it was about 290.8 million, so mine's a little bit above the actual data, but it's still a pretty good estimate. The now try problem number 43 is about the same thing as the example. We're going to use data from 1950 to 2000 and an exponential regression, same thing as before, to predict Los Angeles's population for the year 2003. So these populations are in thousands, so it's 1970,000, so which really means 1,970,000 people. We are not using the Phoenix data, so I'm going to cross that out. Again, in 1950, I'm going to use that as year 0. 1960, I'm going to use as year 10, etc. Now, I put the data for this problem in list 3 and list 4. List 3 is my X values, and list 4 are my Y values. So I'm going to go into stat plot 1 again, but instead of using L1 and L2 for my X and Y values, I'm going to use L3 and L4, just because that's where I put my data. You may have put yours in L1 and L2. And I'm going to hit zoom 9. So I can see my data points. So now I need to calculate my exponential regression. Stat, calc, and we said that was 0. My X list is now in L3. My Y values are in L4. Frequency list can be left blank. I want to store my equation into Y1, so alpha F4 Y1. So there's my equation for my exponential function. And I can see my exponential function following the data. I'm going to hit trace, make sure I'm on my Y1 graph. And let's see, the year, where are we? Here we go. The year 2003 is 53 years after 1950, so I'm going to put in the x value 53. Now my exponential regression came up with 3,981, whereas theirs came up with 3,820,000 people. So again, mine was a little bit over, but still a very accurate prediction for what might happen in the year 2003.